this video, we'll take a look at the kindergarten standard for geometry number 4. This standard asks that students be able to analyze and compare both 2- and 3-dimensional shapes, and they should be able to compare these shapes no matter their size or orientation. And as they do this, it's okay that students are using informal language to describe the similarities, differences, and parts of each shape. Typically, this is the type of triangle that kindergarten students see. So what we have to do is make sure that we don't build on this misconception right from the get-go. So how can we fix this? Well, we don't ever draw a triangle like this. We draw triangles like this. That's right, it's not sitting on its base. We also want to introduce students to different types of triangles. The more that we can show students the variety in triangles, the more that the focus is not so much on the visual, it becomes more on the attributes of the shape. As we begin to do this and show students different types of triangles, the big piece here is that students are really building an understanding that they'll need in first grade. And what's great is that the progression from kindergarten to first grade, well, it aligns beautifully. In first grade, students will distinguish between defining attributes. So they might begin to compare rectangles and triangles because they know that they don't have the same number of sides. As students are beginning to explain and justify their reasoning, what they're really doing is diving into standard of mathematical practice number 3. In the upcoming video, you'll see students construct viable arguments, and you know what? It's okay that they're able to critique the reasoning of their peers. Let's see what this could look like in a kindergarten classroom.
All right, what I want you to do is I want you to talk to the person that's next to you. What do you notice about these shapes? Just turn and talk to the person next to you. What do you guys notice?
So after giving the students some opportunities to explore these different shapes, we asked the ladies to go ahead and find all the triangles and all the boys to find the rectangles. Let's take a look and see how they did.
Now, boys, let's take a look and see what shapes the girls have. Girls, let's see your shapes and we'll see if we agree or disagree. Can you go ahead and lay them on the ground for us? Slide them over this way a little bit. There you go. All right, so tell us, girls, what do you have there? How many triangles?
4.
And how do you know that they're triangles, ladies?
Because they all have 3 sides.
Because they all have 3 sides. All right, let's take.
A triangle has 3 sides.
So a triangle has 3 sides, and all of those have 3 sides. And this one, isn't this one a triangle too?
No.
Why is it not?
Because it does have 3 sides.
Okay.
And
Before we take a look at the boys' reasoning, let's go ahead and take a look at some misconceptions that begin in kindergarten. When the boys are comparing the squares and the rectangles, you'll see that they don't see the similarities in these two shapes. Here's what I mean. Well, they don't see that all squares are rectangles, but that not all rectangles are squares. Now, granted, this is a really abstract idea for kindergartners to wrap their heads around, but it's definitely something that we need to have students understand by the time they leave us in first and second grade. So let's start going and developing this understanding from the get-go. We want students to see that squares are really special types of rectangles. The other piece that you'll see as you watch this video as the boys explain their thinking is when they have a square, that when they rotate it, they think it changes from a square to a rhombus. The big piece here that we need the students to see is that regardless of orientation, the shape actually stays the same. This is still a square, and all squares are rhombus, but not every rhombus is a square. So just take a look and see how these misconceptions can begin to develop early on in a kindergarten classroom.
So, ladies, let's take a look at some of the shapes that the boys have. Let's take a look at some of the shapes that the boys have. Boys, what shape were you guys looking to find? So can you put your shapes down here and let us see them? What shapes are those? So you have some rectangles. Let's take a look. Let's take a look at your rectangles. So you're saying this is a rectangle, this is a rectangle. What else is a rectangle? Do you have any other rectangles?
we built one.
What do you notice here? Are both of these rectangles?
No,
You're saying no. Why no?
because this one has points.
It has points.
Like,
Well,
it
okay.
has points, and regular rectangles are not like this.
But what is if that's not a regular rectangle, what is a regular rectangle? All right. And are there any other regular rectangles? What about those two shapes that are in front of you? What are those shapes?
Squares.
And how do you know that they're squares?
Because if I split them in half, they're squares. And then if you make it,
What did you just
I
say?
still think that one's kind of a rectangle.
What makes it kind of a rectangle?
Because it's kind of long. And rectangles are long.
So are one of those are longer than the other?
Yes.
So which one of those is a rectangle? So what makes that a rectangle?
Because how long this is.
Ah, and what do you notice about that shape in front of you?
This is a square
And-
because it has 4 sides.
Well, these have 4 sides, don't they?
Yeah, but they're longer than this. Yeah. They have 4 corners too.
They have 4 corners. So what do you think's the difference between what shape's that then?
A square.
A square. What's the difference between a square and a rectangle? Are they not the same then?
No.
No?
That means they're not like. Difference is that one is shorter and one is longer.
What is shorter and what is longer?
The square is short. Longer. The square is shorter. And then the rectangle is thinner than the square.
The rectangle's
skinnier.
It's skinnier. And look at the sides on that one. What do you notice about all the sides?
They're all equal.
They're all equal.
They're all equal, and you could, if you do it like this, and you make it a diamond.
If you turn it like that, you could make a what?
Diamond.
What's that math word that we use to say the word?
Rhombus.
A rhombus. So what shape could you make?
Rhombus.
And so, because you said that all the sides are equal on that one, what do you notice about a rectangle?
All sides are not equal because. And a short side.
It has a long side and a short side.
That's how it is. If you see the square, it doesn't even fit.
Okay.
It's those two rectangles.
Nice.
Oh, this is the difference between a square and a rectangle. A rectangle has a small side and a bigger side, and a square has an equal side.
All equal sides? Nice. All right. Okay. Good job, guys. Thank you.
It's amazing what students can do when we just give them the opportunity. Here, it might have seemed like there was a lot of shapes for students to make sense of, but when we give students the opportunity to explore, they never seem to disappoint. Another thing to consider while trying to explore these different shapes with students is that we give them lots of opportunity to explore both two-dimensional and three-dimensional shapes. Now, there's lots of ways that students can do this within our classroom, but if we were to take a step outside the classroom and look at this picture of Atlanta, we can see that the building that's labeled Weston is a cylinder. And as students are looking at cylinders, they know that both ends of a cylinder are made up of circles. And it's here that students have the opportunity to explore and connect both two-dimensional and three-dimensional shapes. There's a whole lot happening in this standard. Let's make sure that we don't build on student misconceptions and we give them lots of opportunity to compose, decompose both two-dimensional and three-dimensional shapes and recognize their attributes.